This 5-minute long video explains different ways you can deploy Cerbos, what happens when a Cerbos instance starts, and when a request comes in. The previous video explained how your application would interact with Cerbos. If you have not watched that one yet, we highly recommend you start with that one. First, let's talk about how Cerbos can be deployed in your environment. You can deploy and run Cerbos as a binary on your bare metal machine or VM. Or you can deploy Cerbos as container in your environment. You can even run Cerbos on serverless infrastructure like AWS Lambda, Google Cloud Functions, or Google Cloud Run. If Cerbos is deployed to a container orchestrator like Kubernetes, it can be run either as a standalone pod or as a sidecar. Cerbos is a stateless decision engine that will make decisions based on the incoming request and the provided policies. When Cerbos starts, after reading its configuration file, it finds its policies and loads them into memory. It uses these policies to make its decisions. The policy files are where the access rules for each resource and action are stored. In addition to the resource policies, these files can also include definitions for derived rules, individual principal policies, and request attribute requirements. Cerbos does not have to reload or look up the policies every time it gets a new request. However, on a periodic basis, it can monitor the storage for updates and automatically hot reload the latest policy. Alternatively, one can always use an admin endpoint to force a refresh of policies on an instance. The policies can be stored in 3 different main storage types: Git, disk, or database. For Git-based policy storage, Cerbos is capable of storing and checking policies from any Git repository and branch you give it access to. Cerbos also comes with a full unit testing framework and GitHub Actions, making deployment of policy changes via CI/CD pipeline easy to implement. Policies can also be stored on a disk. If you choose this option, a typical installation usually has the policy files with the codebase or on a cloud storage location such as Google Cloud Storage or any S3 API-compatible cloud storage. Finally, you may choose a database-backed storage. This is an ideal solution if your application is planning to make programmatic changes to the policies. You can connect to the admin API to make changes, and it will automatically take care of all the change management and the audit trail. Currently, Cerbos supports SQLite, MySQL, Postgres, and MS SQL out of the box. No matter which storage method you choose, you can always use Cerbos' unit testing framework and policy validation tools before making changes to your environments. Once the policies are loaded, the Cerbos instance is ready to process incoming requests via its REST and gRPC APIs, and logs both the requests it receives and the decisions it makes. Let's take a look at what happens when a request comes in. There are 2 main types of requests your application can issue to Cerbos. One for checking permissions, either individually or in a batch, and another one to get a query plan. Every request that comes to Cerbos includes the details and attributes of the principal, and the properties of the resource that the principal is trying to act on. Your application can send either individual or batch requests to the check endpoint for each principal. By evaluating each request, considering the context, Cerbos returns allow or deny decision to each resource and action pair. At this point, your application implements how it should proceed if the action is allowed or how to proceed if the action is denied. This way, when the decision-making logic changes, your application code does not need to change. Another request your application can send to Cerbos is a request for a query plan. This is useful if your application has millions of objects it needs to quickly filter based on the user's permission. An example of this would be, in order to render a listing page seeking Cerbos' help to fetch all the objects the user has edit permissions on, or delete permissions on, and so on. Cerbos is also capable of giving you the filtering logic your application needs to apply against its data storage to fetch the right objects the user has permissions to perform the specific action on. The Query Plan API returns an AST, abstract syntax tree, that you can implement in your application's data fetching layer. If your application is in Node.js, Cerbos has a Prisma package you can use out of the box. We hope this has been a helpful introduction to how Cerbos works. Now that you have an idea of how Cerbos works, explore the interactive diagram to check your understanding, or head over to the documentation to learn more.